To continue on with nomenclature, in this video we're going to deal with nomenclature two other types of compounds you won't come across too often, but that said, it's still useful to know how to deal with them when you do come across them. So the first type of compound are hydrated compounds, and so hydrated compounds contain water combined in the structure. And the second type of compounds are hydrides. Hydrides contain hydrogen, but in this case hydrogen's acting a little differently. So why don't we get started? So hydrates, as I mentioned, they're ionic compounds, but they also have water in the form of H2O combined in their chemical structure. So we have to be able to deal with that water. The amount of water is fixed by mass. We'll deal with that a little later in the year. And hydrates typically lose their fundamental structure when you remove water. And so I can show that with these two examples here. So here is a particular compound, hydrated cobalt 2 chloride is this red color. It's granular. It's almost like granulated sugar. If we remove all the water by heating, we get anhydrous cobalt 2 chloride. So this compound is much more powdery, and the color has changed. So the water clearly has an impact on what the compound looks like, and it will to some degree have an impact on how it behaves as well. When you remove the water, the compound is said to be anhydrous, or without water. So that's just a little bit of background. Now, in terms of nomenclature, it's really straightforward. The first bit is an ionic compound, and you've already seen that. The second bit is the bit dealing with the water. And here we have a prefix, and again, the prefix is the prefixes you've used to name molecular compounds, mono, di, tri, etc. And then we have to add a suffix, hydrate, to indicate that we have water present. So COCl2.6H2O. So COCl is the ionic compound, so that's cobalt 2 chloride. So there's the ionic compound. And then 6H2O. 6 is hexa. And we add hydrate to say that it's water. 6 waters. So if you want to write a formula, well, it's the same thing. It's just naming an ionic compound and then, writing a formula for an ionic compound and then including the water. So magnesium sulfate, MgSO4 is magnesium sulfate. And so we have this little dot, heptahydrate, 7H2O. And we include this little dot as part of the formula. So you need that there, and that just says magnesium sulfate is combined with 7 waters. Okay, so that's hydrates. Pretty straightforward. Hydrides are just as simple, and in this case of a hydride, we have a metal combined with hydrogen. But in this case, it appears that the hydrogen in that is acting as a nonmetal, and so it's going to have a charge of -1. So hydrogen in exactly the same way as ionic compounds, metal, then nonmetal ending in "ide." But remember, it's always hydrogen, so it's hydride. So sodium, or NaH, would be sodium hydride. Calcium hydride would have the formula. Well, calcium has the charge of 2+, so that's Ca with 2+, and hydrogen has a charge of 1-, so it's H2, CaH2, calcium hydride. So hydrides are really straightforward. You're just remembering that hydrogen is going to come second, and it has to counter the charge of the metal, the positive cation. Just a few examples then to finish off. CuSO4, 5H2O. CuSO4 is copper 2 sulfate, and there's 5 waters, so that's pentahydrate. Sodium carbonate tetrahydrate. Sodium, Na, carbonate is CO3 2-, so it's Na2CO3, and we have tetrahydrate, 4H2O. Sr H2. That would be strontium, Sr, hydride. And finally, cesium hydride, Cs, and Cs has the charge of 1 plus, so CSH. So there you go. That would be naming and writing formulae for hydrated compounds or hydrates, and naming and writing formulae for hydrides, compounds containing molecular hydrogen or containing hydrogen. And so that concludes this video.